Okay, here, these things is starting to be out of syllabus, but this is already the last hour of my 5 lectures. So let me introduce what you can go forward even beyond this course if you are interested in research. So you have to choose physics parameterization scheme when you run real simulation jobs. So how do you know more about what the choices are? They are actually hard. So the hard ways are read the original paper I have shown you. For example, you may be curious how the diagnostic U10 is calculated. And then I will tell you it is calculated by a surface layer model. So you will go to, and now you are running CPAS, so you will look into CPAS documentation, and I can also show you here. So you go to the web page originating the software you use, and then you just browse what are there to read. And then I encourage you to take a glance at every page. And then from a support page, you may find user guide. You are using the software. It is natural to read the user guide. And then you are running real simulation. So you click into it, and then you are told from the instructor it is related to surface model. So you search for surface. Okay, no, nothing called surface, but it is related to surface layer model is actually related to PBL scheme. I will talk about it in this hour. So you go to the most relevant section. There's no table of content. So you just scroll down looking at these headlines. Options, something relevant. Options for real simulation, yes. And then job particulars, you know it. Data source, you know it. CPAS model version. And then something not relevant. And then this is relevant. So you just do this reading and skip the sessions you don't want to read. And then you reach here, you can choose convection scheme and PBL scheme. So here is the list of available choices. And then we have done the job of telling you the original papers like this. And for PBL scheme, which is related to because it is boundary layer. And then I will talk about it later. And then there are 2 choices. So you can go ahead and read the paper like this. And then very often it goes to the journals page of this paper, and then it is not convenient to read. So you find PDF, and then you download PDF and read the title, read the abstract, see whether you are still interested, and then take a glance. Okay, let's go back. This is the hard way, one hard way. The other hard way is to find reference in some source code. So I will give you an example. Some source code has a documentation header, but not all source code are well documented. So CPAS is derived from MPAS, and then MPAS source code here. MPAS source code is put to GitHub, and then the organization make a user account CPAS development, and then this is the source code of MPAS model. And take the example of you are looking at atmosphere physics taken from WRF. So this is the simulation program, which is called core atmosphere. And then it has its dynamical core and physics. So you choose physics. And then these are some integrating code. Actually, the physics module are taken from WRF. So the subdirectory is called physics WRF. And then you are interested in boundary layer. So these are the source code from YSU and MYNN. This is the MYNN PBL schemes source code. So you will see some documentation block. So it tells you the origin of the implementation is in MPAS is from WRF and also its version, and then some note for the developer and maintainer. And then sometimes you will see papers there. And then these are Fortran source code. So go back to the example. If you want to look at the things about the cumulative scheme anti-TKE, you can do so. Oh. Again. CU physics, these are the source code of the 4 choices, and then new type TKE. And then you see the documentation block. And then you may see some paper. Things like that, okay? And for surface layer model, we cannot find information from MPAS page or CPAS page. So you get to go to the WRF page. WRF page here. You have the surface layer here. And then you see these things. Some are the PBL scheme, and some are actually what's called the surface scheme. So you may access the paper, read the abstract to see if you are still interested. WRF surface layer formulation. And then this is actually, I will show you. Something about the vertical height of the layers. As you will see, the lowest layer has the height 46 meters. So, and then one vertical layer higher, it is already 106 meters. So you will curious how are the temperature at 2 meters above ground level calculated. It is already lower than the lowest level. And also for the wind components at 10 meters above ground level. So this is the lower part of the boundary layers. In numerical models, okay, go back to that figure, this figure. As I mentioned, different NWP model have some factoring of the schemes into modules. So in WRF and in CPAS, this PBL module is actually subdivided into two modules. One is PBL itself, the other is surface layer. So if you become familiar enough with WRF, then you will check that this out of this group, there is also one thing called surface layer physics. So there are some options. One option is specific to MYNN. If you use MYNN as your PBL scheme, then you need to choose a matching one. And then for YSU, you may heard that it uses similarity theory. So you look for similarity, and then since two are related, and then you dig in more, you find that YSU pair with this, usually pair with this scheme. Okay, so it takes much more work to be familiar with this. And then you read the paper and search for related material, you will find out the formulation of calculating variables at 10 meter and 2 meter above ground level. I will not go into detail here, but I would like to let you know how you can go deeper. The other way to do so is Google searching. Try to find some more digestible material like regular conferences. And then Google search for slides and presentation. So I will also give an example about this. Okay, the hard way, still the hard way, still the hard way, and then more digestible way. One important regular conference is called WRF and MPAS workshop. It is organized by NCAR. You may Google search it, but usually they only keep the latest one. So the latest one is this 2002 agenda. Actually, my colleague just found it this morning. And then this is going to happen when you are having your project presentation. So these are the topics that people are doing the, what we say, leading edge research, okay? So you will see some topics in this year, but I want to show you something I highlight here. I have mentioned that scale-aware physics is a topic of research right in the recent years. So it was just 2 years ago. You see these topics: introduction to scale-aware physics, and then some more topics like scale-aware treatment of subgrid mixing, and then convection, okay, something related to convection, and then also convection, and then dependence of deep convection schemes on horizontal grid spacing in MPAS. So you see these are very relevant topics. And this one is from 2021, last year. You will see overview of physical parameterization development for the unified forecast system. And topics like that about complex terrain. Okay, microphysics, this one. This one is an interesting topic. I pick it as an example. So currently you have only two choices of microphysics scheme, which are quite complicated, and actually the performance is not very satisfying. So just in last year, we see that from these conferences, one new microphysics scheme called P3, or predicted particle properties, which has a very different approach from the existing 2-1. So if you are interested, you may search for slides and presentation, and then you may click into it. And then, where is it? Morrison, okay. Microphysics. And then you see presentation slides. Very nice slides. It tells you about microphysics. It's complicated. And then approaches. Some approaches called bulk and other approaches called bin. And then some old scheme, and then stage of the art existing scheme. You see what I have mentioned, Q, the mixing ratio of QV, QIs, QG, ground poles, QS, snow. Some have number concentration as well, and then this becomes very complicated. But these authors start to use another approach to formulate it, not to classify, say, ground pole and snow as two categories, but use some continuous number to model it. So this continuous number is called properties. So it is predicted particle properties. So this approach is out. These researchers try to implement their ideas and then perform experiments, and then they will compare the results of their experiments with others. And then it seems that the outcoming results is good. So the research community many people in the research community think that it is good, and then it will appear in the conference. And then if people want to use it, they go to the open source world and then see if it is in the release. If it is in the release, then people can use it right away. If not, then they have to do some software integration like that. So this is what latest research and application going. Actually, in this year, 2019, we also have a presentation in the NCAR workshop on hierarchical time stepping. Okay, so this is the way we join international research. And then sometimes we Google search a topic and find presentation not in this conference, but in other conference. And some presentation will be recorded and provided as YouTube video, say for the topic gravity wave breaking or gravity wave drag. Say I found this presentation in this UFS, Unified Forecast System webinar, very useful. Then I just spend 1 hour, watch the video. Actually, I spent more than 1 hour. I pause and then think about it and then go on like that. And sometimes we can find very useful information from these presentations.